Hey everybody. So today we're going to talk about chapter 6, section 1, which is all about congruence and congruent polygons and what is congruence. Basically, we're going to talk about what a congruent statement is and how we use it. And we're going to talk a little bit about proofs, and I'll show you how those work. But when you do proofs, don't be too concerned. They're not going to be as complicated as they appear. So anyway, I thought we'd get started with the note sheet that's going to be available on Google Classroom, and I'll walk you through it. So congruent, something we already know. Congruent means same shape and also the same size. And we've worked with congruency already, but this is going to kind of take it to the next level. So the first thing it asks us here, are the figures congruent, why or why not? We look at these three figures, and they are the same shape and they are the same size. So yes, because they are the same shape and the same size. Okay. How about these? Are these figures congruent? Why or why not? Well, no, they're not. They're the same shape, but they're not the same size. These would actually be considered similar, which we'll be learning about fairly soon, but not yet. So we're going to say no, same shape, but not same size. Same size. Okay. Definition of congruent polygons. Polygons that are same shape and size. And polygons, we'll remember, are closed figures, closed multi-sided figures. So examples of polygons would be triangles, quadrilaterals, pentagons, hexagons, heptagons, octagons, and so forth, and they go on and on and on. Okay, congruent corresponding angles. Okay, so angles that correspond between congruent figures are congruent. And this will make sense in a second. Oh, that's terrible handwriting. I apologize. Congruent corresponding sides. Sides that correspond between congruent figures are congruent. Now, what does that mean? All that means is that when you have two shapes that are congruent, the corresponding angles and sides themselves will also be congruent to one another. So here's an example right here. Let me zoom in here. So these two triangles here are actually going to be congruent. Okay, and I'm going to write a congruency statement to help us work with these. So we're going to start with the top triangle. And I'm going to count by the number of arcs. I'm going to go 1, 2, 3. So BAC. So triangle BAC is congruent to triangle. And now we go 1, 2, 3 again over here. So 1, 2, 3. So JHK. JHK. Okay. So that's the congruency statement that describes what's happening with these two triangles. And we can use that a bunch of ways. So we know that B and J would be congruent, A and H would be congruent, and C and K would be congruent, because those are corresponding angles. The sides as well would work. So BA and JH would work, AC and HK would work, BC and JK would work. Those sides would be corresponding and they'd be congruent. As indicated by these markers here, you can see, right, this is BA, right, the first two letters. Therefore, the first two letters over here should work, it's JH. And you can see that they both are marked with one tick mark, so therefore, yeah, that works. So the order of the letters is actually very, very important when it comes to the congruency statement. All right, so congruent statement, yep, statement that indicates corresponding sides and angles of a pair of congruent shapes. Yeah, this is very useful. We'll be using that quite a bit. So the ability to look at this and extrapolate information from that's very important. Okay, so this question down here, if triangle, let me zoom in so it's a little better to see. if triangle MIC is congruent to triangle KEY, list all their corresponding congruent parts. So we'll do the angles first. So it's going to go letter by letter. So M is going to be congruent to K. I would be congruent to E. Kind of messed up that congruent sign. C, so angle C, is congruent to angle Y. So those are the angles. Let's do the sides. So we'll do the first two letters, so MI. So MI, what is it? Is congruent to the first two letters over here, which is KE. Then the next two letters are going to be IC. Oh, you can't really see that, can you? IC is going to be congruent to EY. And then we're going to do the first and last, so MC and KY. KY. So this would actually tell us which pieces of each of the triangles would be congruent to one another, just from that statement. Okay, pretty cool. All right, now this is an interesting acronym. All right, so CPCFC, which means congruent. Oh, sorry, not congruent. I already screwed that up. Here we go. Corresponding parts of congruent figures are congruent. Well, what does that mean? That means that the pieces of the triangles that correspond to one another, in this case triangles, but any shape, given that the shapes themselves are congruent, means their corresponding elements are also going to be congruent. So that means if you have two, for example, let's use these triangles, right? So if these are going to be congruent, it means there's going to be matching sides, there'll be matching angles, and that can all be extrapolated from the congruency statement, which we have here actually. Let me zoom in a little more. So triangle ITP is congruent to triangle NGO. So find the values of x and y. All right, so they give us the congruency statement. We're going to use this to find the values of x and y. You'll notice x is over here. That's a two-variable statement, so that's not going to be very helpful. We're going to go down to here, y is by itself. We're going to try to solve y first. So O, okay, this is part of angle O. So O is here, it's the last letter. It's going to match up with P. So P and O match up. So I can set P equal to O and solve for y here. Because P is 40 degrees, which means this whole thing is 40 degrees. So we're going to say 40 degrees equals 6y minus 14. Yeah. We're going to solve for y here, so we're going to add, actually I'll use a different color for that. Plus 14. So 54 equals 6y. I'm going to solve that algebraically, so we're going to divide by 6. And that is going to be 9, so y is equal to 9. Okay, that's not too bad. So we can change this to x minus 8, 2 times 9 is 18, so x minus 18. Now NG are the first two letters here, which means NG will be congruent to IT because of the first two letters there. So IT is 7.5, so it's going to be 7.5 is equal to this. So 7.5 is equal, that's IT, right? Is equal to NG, which is x minus 18. So we're going to solve for x. We're going to add 18 to both sides. And that's going to be 25.5. 25.5 is equal to x. And that's that. Okay. All right. Now this is the weird part. So this is a proof. Okay, it's given us these two triangles. Oh, before we do that, actually, hold on. Before we do that, we're going to go to the third angle theorem. And third angle theorem tells us that if two pairs of angles in a pair of triangles are congruent, the remaining corresponding pair is also congruent. So what that means is basically if you have 2 out of 3 angles, like for example here, these 2 angles are congruent, these 2 angles, that means these 2 angles have to be the same, which we'll get to. But we're going to kind of prove it here. So we're being given this. We're being told, okay, well these 2 are the same here. Okay, so we're going to prove that these 2 angles are the same. And we're given all this information. We're given, okay, these 2 triangles, we're told that B is going to be congruent to J and C is congruent to K. Okay, prove that A and L are congruent to one another. This is those angles. We don't know if the triangles are congruent because, again, they could have the same angles but be different sizes, but they could be the same shape, right? So there's a series of statements here on the left, all right? And how a proof works is you're told things, and there's, well, you're saying things, and there's a reason why, right? This is a 2-column proof. When we do them together, you're actually going to have the options to plug in here, so you're not going to have to just fill in half a proof like this. But I'll walk you through it. So it tells us that angle B is congruent to angle J, and that angle C is congruent to angle K. The reason for that is that's given. We're actually, oh, I think my camera just froze. Hold on a second. Let me try to fix that. All right, there we go. Sorry about that. All right, so yeah, so we're told that these 2 angles are congruent, and these 2 angles are congruent, and that's because it's given to us, okay? We then go on to say that the angles are equal. The measure of the angles are equal, and that's just the definition of congruent angles. All right, so if angles are congruent to one another, it means their measures are equal. And that again, that's just the definition of congruent angles. Some shorthand notation here. All right, now we say that angle A plus angle B plus angle C equals 180. We say the same thing about angle L, J, and K. So those are the interior angles here, and that's called the triangle sum theorem. We learned about that before. And that tells us that the angles within a triangle will always add up to 180 degrees. Okay. Number 4, it says angle A plus angle B plus angle C is going to be equal to angle L plus angle J plus angle K. Now what happened here is we said that these things here are both equal to 180. So if this is equal to 180, this is equal to 180, that means they're equal to each other, right? That's the transitive property. You guys learned about that in algebra, right? Remember, if A is equal to B and B is equal to C, A is equal to C, that's essentially what we did here. We said these 2 things are equal to this, therefore they have to be equal to each other. Okay. Now 5 here, it looks like we took J and K and plugged in B and C. And that goes back up here, because notice we said J is equal to B and K is equal to C. Well, that we ended up using that down here. We just substituted. You can see what's happening here. We're trying to get A and L by themselves, which is what we're trying to do here. And that's just substitution, okay? Now to go from here to here, we literally just subtracted. So we said, okay, well I'm going to subtract the measure of angle B. I'm going to subtract the measure of angle C. I'm going to do that to both sides, right? So subtract the measure of angle B, subtract the measure of angle C. We just did that algebraically, and we're going to get, you know, angle A is equal to angle L, the measures of them. So that's just because of subtraction. And then the last part, which is up here, is now these angles are congruent to one another, and that is the definition of congruent angles. So it's a little confusing because we go from the angles are equal to, the measure of the angles are equal to each other, to the actual angles themselves are congruent. Okay, and that is something that throws people off. So when we do these, again, you're not going to have you're not going to have one blank column and filling it in. You'll be given options, and we're going to work through it. We're not going to spend a whole lot of time on proofs. I don't think it's that important. You don't really see a lot of it anymore. We'll use it, we'll get used to it, but we're not going to spend, a ton of time on it. Now these are some properties you can refer back to as we work through some of the problems. And here's another 2-column proof I'm going to walk through here with you. So we're given these 2 triangles. Let me zoom in here so you can see a little better. You're given these 2 triangles here, and we're given here. So angle L is congruent to angle P, which is already marked here for us. We're told that these 3 sides are congruent. So LM to PO, right? So it's marked with a single tick mark. LN and PN, which is 2 tick marks, and then MN and then MN and OP. Now, that doesn't look right. I think that's a mistake. That is a mistake. That's a typo right there. So this should be LM is here, and OP. That works. A single tick mark. LN and PN. That works. And then MN. Now this is a typo right here. So MN should be congruent to NO. So good thing we checked that, guys. Okay. All right, so let's check this out. So it's asking us to prove these triangles are congruent to one another. So again, we basically just repeat the given here. That's the given. Then we say that angle LNM, so LNM, is congruent to angle PNO. So these are the two angles we're talking about. Yeah, I'd agree with that because those are vertical angles, aren't they? So definition of vertical angles. We're then going to say that M and O are congruent, so I'll use 3 tick marks there. And I'd agree with that as well because of third angle theorem, right? So we have 2 pairs of angles that are congruent, therefore the last pair has to be congruent. It's third angle theorem. And then, okay, so we're saying that all the angles are congruent, all the sides are congruent. And the definition of congruent triangles are the same shape and same size. So that's that. All right, so that just walked you guys through all of that. Don't worry too much about the proofs. We're not gonna spend a whole lot of time on it, but I think it's important for us to get some sort of exposure to it. I'll be assigning some work on Google Classroom, and we'll be working on it tomorrow in class. So look forward to seeing you guys. All right, take it easy.